All right, so today's lesson is going to be on phase diagrams. So when we look at a phase diagram, this is another way of representing all of our different phases. All right, so here's my solid phase, here's my liquid, and here's my gaseous phase. So this line right here represents melting as I go from a solid to a liquid. If I come back and go from a liquid to a solid, it would be freezing. So this line is my melting and freezing line. As I go from a liquid to a gas, all right, as I go from a liquid to a gas, we say that we are undergoing vaporization. And as I go from a gas to a liquid, that is condensation. So this line represents a vaporization and condensation. All right, as I go from a solid to a gas, that is sublimation. And as I go from a gas back to a solid, that is deposition. So this line represents my sublimation and deposition. All right, at this point right here, where my solid, liquid, and gas all meet, we call this the triple point. This is the point in which all three phases will exist at equilibrium at the same time. And this only happens at a very specific temperature and pressure. P for pressure, T for temperature. So this is the pressure and temperature at which we can have a solid, a liquid, and a gas all at the same time. Up at the very top, this right here, where my liquid and gas kind of come together right here at the very top, we call that the critical point. All right, we call that the critical point. That is the point at which a phase change can no longer occur regardless of a change in temperature or pressure, because at that point the density of the liquid equals the density of the gas. So let's write that down. Point at which a phase change can no longer occur. There we go. Put this back on the screen there for you. No longer occur, regardless of temperature or pressure. Okay, the density of the liquid equals the density of the gas. All right, so our next question asks us, is the density of the solid greater than that of the liquid? All right, or less than. So is it greater than or less than? So what we're going to do here is we're going to come up and we're going to look at the slope of our line. The slope of this line is negative. A negative slope tells me that the density of the solid is actually less than that of the liquid. So a positive sloped line would tell me that the solid is greater than. So you can look at the slope of the line to determine the density of the solid versus the liquid. Would an increase in pressure cause this substance to freeze or melt? All right, so let's come back up here and let's take a look at this. And let's look at a constant temperature. All right, so I'm just going to draw myself a dotted line here to represent a constant temperature. Now, if my temperature stays the same, but my pressure is increasing. So as I go to an increase in pressure oops, I just drew the line on the pressure side. My goodness. Let me change that. I'm sorry. Let me change that up, my friends. Okay, we want a constant pressure or constant temperature. Okay. All right. So as I go, my constant temperature here, as I increase my pressure, I notice what is happening. My liquid particles are going to become, well, let's talk about this. Let me stop for a quick second. An increase in pressure is a decrease in volume. So if I have a system with 3 particles, if I increase the pressure, I decrease the volume. So what does that do? It forces our particles to be closer together. And so which one of these is going to have particles closer together? And that's going to be freeze. All right. If we freeze, we push our particles closer together. All right. And we're going from a liquid to a solid. And we know in the solid phase, those particles are closer together.